Okay, good afternoon. My name is Isabella Velasco. Today I'm going to talk about Prestress, Masonry walls. Before I start, I wanted to show a quick example of how Prestress is used in building some structures previously. And this is in Sydney, Australia. This building was built in the 1800s. And the history behind it is a little bit long, but the main focal structure that I would like you to pay attention is to the clock tower. The clock tower was destroyed and rebuilt several times, and the last ownership decided to reinforce or to make a more stable structure, so they decided to use prestress struts. And this is the detail that I was able to find when they use vertical and horizontal prestresses. So prestress has been used for several years. Okay. Now, what I'm going to be talking about in these presentations is first give you a background on what is prestress, and then we're going to go over the construction methods, the behavior of a prestress masonry wall under lateral loading, the design methods and codes, a brief comparison between unreinforced wall, reinforced, and prestress wall. We'll go over a few examples and then we'll wrap it up the presentation. First, a little bit of the background. The prestress masonry it's been used in the 1980s. It was studied in the 1980s, and it was finally adopted by the British in the 85 and by the US in 1999. By the code that we use for the design of masonry is state that prestress masonry is the masonry which internal compressive stresses have been introduced by prestress method to counteract the potential tensile stresses resulting from the applied loads. So I want you to keep in mind this is the key word. We're trying to counteract the potential tensile stresses. That's what basically our design is going to be about. So if you look at general concept of how we build beams, if we have a concrete beam, for example, we will look that it's going to be a deflection whenever we apply the load in it. Whenever it has these strings, it cracks. And that will be a problem for the structure. When we are reinforced, we have some, we can try to make these beams stronger, but when it has soon it cracks, there is potential corrosion, which damages the structure. As soon as we use prestress, some of the benefits of that, since it's all the time, you try to make in this case, the concrete compression, which it has the most potential strength. Whenever it cracks, it pushes in, so the cracking doesn't go over, and there is no potential of corrosion. So now, how is prestress walls built? Well, you have to think about if you want to do post-tensioning or pre-tensioning. For post-tensioning, you use a hollow masonry, and for pre-tensioning, you use an A or an H-shaped masonry. You have tendons that vary from a half an inch or 3/4 of an inch. You can use bars. You use anchors and grafts. So this is a detail of using a bar in the masonry. Now, what is pre-tensioning and post-tensioning? Well, pre-tensioning is whenever you first stretch the tendons or the bars, and then you build around it. That's what we usually do for precast concrete or regular prestress concrete. For post-tensioning, you first, for example, build the structure. In this case, they build bar into the foundation, this is the roof slab, and then they put the masonry around it, and they anchor it, and then they jack it up with certain load that you will specify. This is an example how they do it, and depending on how much you have to do, they use equipment where you measure how much force you are adding whenever you are jacking whenever you're adding the stresses into the rods or the strands. Between pre-tensioning and post-tensioning, post-tensioning is the one that we use the most for masonry construction. And what are the benefits? Well, you have this reduction of crack because that's it. You minimize the flexure tensile stresses. As well, whenever you apply those loads compressing the masonry, you avoid, whenever there's formation of crack, they put them together again. And for that reason as well, you have less water penetration, which is reduced corrosion. You have less grounding to be used, depending on which one you're using, because if you use pre-tensioning, it will be different. For post-tensioning, you don't need to use as much. And way to reduce the load, you have a reduction of the weight of the building, which you have to take in consideration those kind of things whenever you're designing, because now your support's not going to be having the same load than before, or if you use another type of construction. You can improve the insulation if you use different systems like the integral insulation, where you place the insulation in between where the grout is supposed to be. And depending on the design, it could be an easier construction. You can create partial walls. You can create. It is easier, but at the same time, you have to be careful of how much of the hardware you're going to use for your design. So the part of the benefits of the pricing, it may vary on your design. Now, whenever we apply a load, when it's a wall increase with post-tensioning or this type of pre-stress rods, you have in the masonry, you have the stresses due to the tensioning of the struts, or in this case a rod, and you have the bending stresses due to the lateral loads. In this case, could be wind, could be seismic. As a result, in your design, you try to make that it's always in compression to after you are loading the structure. So, whenever we study or analyze this type of structures, we study or we look at their behavior. And for a pre-stress masonry, is affected by the level of pre-stress, whether if there is a bond or unbound struts, or if they are guiding on guiding tendons. For post-tensioning wall, they behave elastic on cracking, and then they go over a non-linear behavior until failure. The walls and unbound lateral restraint tendon affect the ultimate strain capacity of the wall because they lack of restraint of the pre-stressing steel. And after cracking, later deflections occur, but the tendons remain straight. So you have to take those things in consideration. That's the fundamentals of the design of pre-stress masonry walls. In your code, in chapter number 4, you can go and get the guidance how you're supposed to design it. And how I said, you consider you do an elastic analysis. For you pre-stressing, these are the requirements. They cannot go the jacking force, which is the force that you apply to the tendon. It cannot be larger than 0.8 of the stress capacity of the strength, and it cannot be more than 0.94 of the capacity, the yielding capacity of the steel. Besides, these are other requirements that you probably can look at on your own. One of the biggest things that pre-stress masonry compared to regular reinforced bars or designs of reinforced concrete is that now we're counting the effective stresses which they are affected by the losses caused by the anchor, seating, the elastic shortening, creeping, shrinking, sterilization of the steel, friction, the moisture of the clay on the masonry, and the thermal effects. Has around numbers in different places. They have used like a percentage where they say, for example, in the UK they use about 20% losses for brick, and they have they use 35% for the concrete masonry units. For Canada, they use 15 to 25, and for the code that we use, they use between 20 to 25 for brick and 30 to 35 for concrete masonry units. Another losses that you need to take in consideration is the losses after jacking, which is, according to the code, between 5 to 10%. These are some of the strict requirements that you need when you're going to be using when you're designing for pre-stress masonry walls. And you have to take really close consideration on these equations have changed from the previous code to this one. So if you look at your textbook, it will be a different equation and some differences between the capacity and the allowed capacity of the masonry. You can need to figure out on number one. So take care, look close to that whenever you are designing. These are some of the equations that you use. This is for the stresses. This is for the rectangular compressing block and the nominal moment strength. In this type of wall, we also take consideration of the slenderness of the wall, and we saw some of this diagram before. And we still do elastic analysis. We provide sufficient pre-stressing to avoid cracking at the movement moment. No pre-stress reinforcement may be added to increase the post-cracking flexure stiffness to the wall. So you probably will have a combination of regular reinforcement with pre-stress tendons and the strengths above the stresses above the effective stress may have to be limited to control the post-cracking curvature at the critical section and the related delta P effect. We also have talked about shear, and this is taken into consideration too during the design of pre-stress masonry walls. These are the equations. You just can go again to your code and follow the steps that they give you. Now, a quick comparison between an ordinary masonry wall to reinforced masonry and pre-stress masonry. One of the things that you can look from here is the thickness and the mass space per system. This is from a study done on they did a wall with a different capacity, well, with the same capacity, trying to figure out how they vary depending on the systems that are using. And from the analysis of these three walls, it was noticed that for a small two-story building inside Masonry constructed with the procedure of pre-stress masonry with blocks of natural stone, there is a reduction of mass measured in terms of volume of the used material equals to 44% compared to reinforced masonry. and 67% compared to ordinary masonry wall. So take that in consideration. If you want to save some money and you want to make your structure lighter, which is really good for high seismic zones, you probably would like to go for pre-stressed masonry wall than ordinary reinforced masonry wall. Now, for my examples, I went over you can go to your masonry design guide. On the chapter 11, they have all the specifications and they have all the new requirements according to the code. This is an example for out-of-plane flexure for non-load-bearing wall, and they go over all single steps, so it's a really good way to get it for the guidance when you are looking to do an exercise or designing. You can see some of the go from the design service flow to check the capacity, the string capacity of the wall, to using lateral restricted bone tendons. These problems are long, but they're really specific, which I consider you take a look at them on your own to understand what each equation is done, and they show you what part of the code section are they using and what equation to do. In the same chapter, you can look at Prestress masonry wall studied as a shear wall. And as well, they show you all the different steps that you need to do, and they are according to the code, the new code. So all the equations are right. You can, if you go back to this presentation later, you can always go and refer to these where are the examples, but there are only 2 examples on the manual, so they're easy to find. Okay, now what did you learn from this presentation? Now you have a really basic idea what is pre-stress structures are. And what is a pre-stress masonry wall? You just need to think about and you have to counteract those potential tensile stresses. Now you know a little bit more about the pre-stress masonry wall components, the difference between a pre-tensioning and post-tensioning, advantages of using the post-tensioning method, and an overall understanding of the wall behavior under loads, designs, and where to look for the guidance, the difference between ordinary concrete wall compared to a reinforced concrete wall and pre-stress, and where to look for examples. These are my reference, and does anyone have any questions?